Dear friends, welcome to my YouTube channel. I am Dr. Musaddiqo here. As you all know that in quantum computing or quantum mechanics, exact copy of quantum state cannot be manufactured or made. So for that purpose, we always discuss about the similarities between quantum states. So fidelity is an important concept in quantum computing in which we determine how much similar two states are or how much different two states are. So let's move to our lecture. Fidelity is basically the overlap between two states. Overlap means we always determine the similarity index between the two states, and after calculating the similarity, we can predict about the two states and that how much similar they are. Let's suppose we have two density operators rho and sigma. Rho is denoted by the outer product of psi, sigma is denoted by the outer product of phi. There are actually two conditions to determine the fidelity between these two states. First of all, we have to determine whether they are pure or mixed. So what you have to do in the first step, you have to determine that if they are pure states, then they should satisfy these two conditions. Rho square must be equal to rho, sigma square must be equal to sigma, and their trace must be equal to 1. If you have applied this check and you confirm that these are pure, then the fidelity formula for rho and sigma is given by, which is the trace of square root into square root rho sigma square root rho. You put the values of rho and sigma. Under root rho is equal to rho. From here you can see that if the state is pure, then you can write under root rho is equal to rho. So what you will do, you will put simply the outer product of psi and phi into the relation, and from here you can uh, put simple quantum mechanical tools, and your result will be equal to outer product inner product of phi and psi and absolute mod, which shows that fidelity is a number but a positive number, so its value lies between 0 and 1. So when you calculate the fidelity between two density operators or two states, its value will always lie between 0 and 1. Fidelity, if fidelity is 1 between two states, then it means that there is too much overlap between the two states and are very much similar to each other. If fidelity is equal to 0, then there is no similarity or there is no overlap between rho and sigma. So it means if you calculate fidelity and it is nearly equal to 1, you can say that the two states are very much similar and there is stronger overlap between these two. And if it is equal to 0, it means there is no overlap or there is no similarity between these two states. Okay, this was the check for pure states. Now let us move towards the second condition. If rho and sigma are not pure, if they are mixed, what you have to do, you have to check if rho square is not equal to rho, sigma square is not equal to sigma, and their trace is less than 1, then it means that your density operators are mixed. Then the formula, that formula of fidelity is no more applicable. Then what you have to do, you have to check further two things. First of all, you will see that the rho and sigma will commute, and secondly they must be diagonal in basis and their bases must be same. This is the first condition, that the bases of rho and sigma must be same, otherwise you cannot apply that formula on your density operators to find out fidelity. So rho is equal to this one and sigma is equal to this one. From here you can see that rho and sigma both have same bases, which are ui. So then the fidelity formula will be look like that, where Ri and Si are eigenvalues of rho and sigma respectively. Let's move. The this was all about how we can find the fidelity between the two quantum states. First of all, what you have to do, you have to check if they are pure, then you will apply that formula, and if they are mixed, then you will apply that particular formula. Now let's move to some other properties of fidelity. As I have already mentioned that it is an inner product between two states, so it always gives a number, so fidelity always lie between 0 and 1. And second one is that fidelity is symmetric, so interchange of the position of density operators will not affect the fidelity number. As you can see from here, it is proved, you can check it by yourself. And the third one is that fidelity is invariant under unitary transformation. So you can also check that. No, fidelity can be looked as the transition probability. Transition probability is that you can find out the transition probability by calculating the fidelity between two states. Now what this means? It means that it is the probability that the state rho can be evolved into sigma. The probability that the state rho can be evolved into sigma is given by the square of fidelity. So greater the value of fidelity, greater will be the probability that the rho can be converted into, a rho can be evolved into sigma. And the third related metric is the Boris distance. Boris distance is also a quantifier to check the similarity between two states, as I have mentioned here for the rho and sigma. So dB stands for the Boris distance, and dB square is equal to 2 into 1 minus fidelity, which means that greater the, but one thing you have to bore in your mind here, that greater the value of fidelity, lesser will be the value of Boris distance. So greater value of fidelity means that the two states have much overlap and two states are very much similar. But if two states are very much similar, then the value of Boris distance will be very small. From the formula you can see that greater the value of fidelity will reduces the value of Boris distance. So as the Boris distance value is more close to 0, you can say that the two states are more similar to each other. Greater value of Boris distance leads to smaller value of fidelity, which means that two states have not much overlap. Let us take an example of three different density operators which has been mentioned here: rho, sigma and delta. I left a small quiz for you. First of all, you have to check whether they are pure or mixed state. I have written their fidelities one by one. This is the fidelity between rho and sigma. And its value is 0.996, which is very close to 1, which means rho and sigma have much overlap and are much similar to each other. Second is the fidelity between rho and delta, and this value is 0.774, which is far away from 1. So it means that the fidelity between, or the similarity between rho and sigma is much greater than the similarity between rho and delta. So if the fidelity is greater, you can put this value into the formula of Boris distance. You will see that you will get the smaller value of Boris distance for rho and sigma, but you will get the greater value of Boris distance for rho and delta. From here you can calculate whether two states are similar to each other, how much similar to each other. I hope so you find my video useful. Now kindly subscribe to my channel and like and share my videos. If you have any questions, mention in comment box. I will try my best to answer these questions. Enough for today. I will be back with new video. Allah Hafiz.